Thank you, sir. Thank you. So welcome to all the participants in the Geotechnical webinar series, Advances in Geotechnical Engineering, which is hosted by IGS Shimla chapter in association with Civil Engineering Department, JUIT Waknaghat. Myself, Dr. Neeraj Singh Parihar, Assistant Professor in Civil Engineering Department, will be hosting and will be the coordinator for the entire series for the next 5 days. Now, before we could start with our today's inaugural session, first of all, I would like to present my sincere thanks to the entire IGS community. Our guest of honor, Dr. Anil Joseph, who is the president of IGS, Dr. AP Singh sir, who is the secretary of IGS, Dr. Nilma Satya ma'am, Dr. Ashok Kumar Gupta sir, Vice Chancellor sir, JUIT, Dr. R.K. Sharma, and Dr. Ashish Kumar Rohila, who is the HOD of the Civil Engineering Department, for providing the much needed support for organization of this event. Proceeding further, we will first like to share with you a short video about JUIT, who is also the founding institute of this IGS Shimla chapter, which will be followed by another video on the IGS. I will request Mr. Sahu to please share the video.
Nestled among the mighty Himalayas stands a temple of education, an institution that shapes young minds of today into ambitious, conscientious, and dauntless individuals. Individuals who will become leaders of tomorrow. This is Jaypee University of Information Technologies, Solan, where education meets excellence. Conceived as the joint vision of the Government of Himachal Pradesh and the founder chairman of Jaypee Group, Shri Jaiprakash Gaur, JUIT Solan is the first private university of Himachal Pradesh established in 2002. Over the last 2 decades, JUIT Solan has been relentlessly pursuing its mission of contributing to a better world by cultivating creativity and advancing fundamental knowledge through education among students. Adorning the picturesque slopes of Waknaghat hills in the Solan district of Himachal Pradesh, the university campus spread across 25 acres provides a peaceful and serene setting in the lap of nature for young minds to hone their skills for a brighter future. JUIT offers undergraduate, postgraduate, and doctoral programs in various fields of study to include computer science and engineering, information technology, electronics and communication engineering, biotechnology, bioinformatics, civil engineering, and management.
JUIT has been producing polished graduates who are working as experts in various fields in country and abroad. More than 200 alumni have become acclaimed professionals in countries like Canada, America, and also Europe.
As Dean Academics and Research, I have had the privilege of witnessing a remarkable journey here. We aim to provide an educational opportunity to one and all, irrespective of their background. In JUIT, our main aim is to produce industry-ready professionals and good human beings. From the beginning, our institution has been known for its research and innovation, and now it emphasizes on interdisciplinary research and collaborative work. We are also aligning with the principles of NEP 2020, and following NEP, we are preparing the students to excel in their professional journey. We have been continuously ranked in NAC and NIRF. Now we are also ranked in international rankings such as the Times Higher Education ranking and QS ranking.
We regularly upgrade the IT infrastructure at our university. Recently, we have added a good number of new machines in various labs.
With modern hostels for both boys and girls, faculty residences, a healthy and hygienic students' mess, auditorium, sports facilities, and other amenities. The university campus makes life vibrant and enjoyable for students, both inside and outside the classroom.
Handling 1900 students in the age group of 17 to 23 years is challenging. In JUIT, we create a conducive ecosystem for a student to develop and nurture his or her personality besides the academic curriculum, providing excellent amenities in the hostels, good nutritious food, active sports fields, vibrant and diverse co-curricular activities clubs, NCC, etc. are all domains which fall in my responsibility as the Dean of Student Welfare.
The university exposes its students to placement teams from several well-known companies, and the students here in this university to get placements in the organizations like Microsoft and Amazon.
JUIT Solan stands tall as an institution committed to academic excellence, holistic development, and industry relevance. With its focus on research and innovation, as JUIT graduates step into the professional world, they carry with them not only knowledge but also the skills, values, and perspectives necessary to make a positive impact on society.
Okay, so with this, first of all, we'd like to have a vote of thanks as well as welcome our guest of the day, Dr. Anil Joseph, who is the president of IGS, Dr. AP Singh, who is the honorable secretary of IGS, and our ex-president also is present here. Thank you for coming, sir, Dr. Nareen Savadia. Now, I would like to invite Vice Chancellor, JUIT, Dr. R.K. Sharma, to please present his words of wisdom with us.
Thank you, Neeraj. Am I audible?
Yes, sir. Yes, sir.
Okay, thank you. Thank you so much. Anil Joseph, sir. Thank you for joining. And I'm not sure whether you have actually been here to this campus sometimes or not, but I do invite you to come here anytime you will like to come here. Please do come. Dr. AP Singh, sir. Namaskar, sir, and thank you for joining. So this is the invite to you also, sir. You please do come someday here to this university. And Samadia, sir, namaskar.
Sure, sir.
Please. I know that when you speak of civil engineering, then in our minds always comes the name of the engineering college in Roorkee. Always, I mean, we remember that. And fortunately, I have also done my education from University of Roorkee. I did my MSc Maths, applied Maths, and then MPhil Computer Science, and then PhD in Maths from there. And I used to see the environment there. And I know there are colleagues who have done their education from the same place, Professor Gupta, Professor Ashish, and many others I know. But Gupta ji, there was a different vibration about civil engineering in Roorkee. You see different departments. You see Institute of Hydrology. You see Earthquake Engineering, Civil Engineering Department. I mean, there was a different vibration. And as a student, actually, I could not appreciate that since I was a student of some different discipline. But later on, when I graduated in this field, and then I came to know, and I interacted with the other experts, then I realized that the importance of civil engineering and importance of my own university there. I'm sure many of us might have been associated with that campus in one form or the other. I'm sure. I joined this place in 2021 as a vice chancellor. I'm trying to do the things with the help of my colleagues. And I was told that we have this chapter here, and then I requested them to organize different activities under the umbrella of this chapter. And I thank the organizers for making this chapter live again after some time. Please keep on doing this kind of activities in future also, as it always helps. The young minds to do different ideas, to implement different ideas. And I'm sure that this interaction of the experts will with the participants will certainly give them a flip in their thought process. They will be able to do their work in a more efficient way, I believe. Probably someone else will also tell you this, that, and you might have also seen it, that 2-3 days back itself, this university has been given NAC grade A plus with a score of 3.40. And then this has been possible due to the efforts of the teams here, including the team that is being seen here on the screen. And last year we participated in international rankings, and we have been there in QS rankings also, and also in THE ranking. And if I name the institutions, that will not be a good idea, but we have been bracketed with some of the IITs in the country in QS ranking and also in THE rankings. I know that we have to travel a lot to achieve some thing even better, but I also know that these kind of events which we are organizing here, which certainly be helpful in spreading the name of our university in the community. And I'm sure that if the experts like Anil sir, Singh Saab, and Samaria sir come to this place, we will have a different idea, and probably that will help us in progressing further. With these words, I thank you all for joining, and I'm sure that the participants will certainly be benefited by these interactions. Thank you so much for inviting me. Thank you.
Thank you very much, sir, for your words of appreciation, and we promise to just propagate this chapter to a new height. Now, I would like to request Professor Dr. Ashok Kumar Gupta, who is the Dean Academics and Research of the Institute and also the Chairman of the IGS chapter, to please present a few words for us. Maybe you can just wait for the video.
The Indian Geotechnical Society, which was earlier known and founded under the name of the Indian National Society of Soil Mechanics and Foundation Engineering, was established in 1948. This came soon after the Second International Conference on Soil Mechanics and Foundation Engineering held in Rotterdam. The society was affiliated to the International Society in the same year, and since then it has strived to fulfill and promote the objectives of the International Society. The name Indian Geotechnical Society was adopted in 1970. The vision of the founding president, Mr. Khosla, and the honorary secretary, Dr. N.D. Gulati, was to build the society to promote cooperation amongst engineers and scientists for the advancement and dissemination of knowledge in the fields of soil mechanics, foundation engineering, soil dynamics, engineering geology, rock mechanics, snow and ice mechanics, and allied fields and their practical applications. As the geotechnical community started to grow, the International Society decided to have regional conferences for each continent, along with having 4 yearly international conferences. This is when the first Asian Regional Conference was held in 1960 in New Delhi. India also hosted the 5th Asian Regional Conference at Bangalore in 1975 and the 13th one at Kolkata in 2007. IGS has been organizing national conferences annually in different cities since 1961. The Silver Jubilee Conference was held at Kurukshetra in 1973. 1978's GeoCon was a landmark conference held at IIT Delhi, which was inaugurated by the then Prime Minister Morarji Desai. IGS started the prestigious annual lecture in 1978. A tradition followed till date. The first one was delivered by Professor R.K. Katti. Several others who delivered the annual lectures include Professor Dinesh Mohan, Professor T. Ramamurthy, Dr. R.K. Bhandari, Professor Gopal Ranjan, Dr. B.G. Rao, Dr. N.V. Nayak, Professor G.V. Rao, Professor A.V. Shroff, and most recently, Professor M.N. Viladkar. IGS made an impressive debut in the international scene in 1994 with the organization of the 13th International Conference on Soil Mechanics and Geotechnical Engineering that was held in New Delhi. This was one of the biggest conferences in the history of the international society, and it firmly put India on the international map.
24 years ago, in 1994, the Indian Geotechnical Society organized the 13th International Conference on Soil Mechanics and Foundation Engineering in New Delhi. This conference was a great success. Everything went perfectly as planned. Its technical sessions, its exhibition, its field trips, its delegate interaction, its companions program, its entertainment, and hospitality. Dr. Parry, the Secretary General of the International Society, in his concluding remarks, branded the conference as the Magic Carpet Conference.
The turning point came from the 12th Annual Regional Conference in Singapore, which saw more than 20 Indian participants and the keynote lecture by Professor Madhav. We were successful in winning the next ARC at Kolkata and also Professor Madhav as Vice Presidentship for Asia for the term 2005 to 2009.
The major visible contributions from Indian Geotechnical Society have been in the latest 21st century. A large contingent had attended the Singapore Asian Regional Conference, followed by election of Professor Madhav as the next Vice President for the term 2005-2009. Several of our members have been, members of IGS have been members of the technical committee, and the most recent achievement of our society has been the keynote lecture or plenary lecture given by Professor Babu at the Seoul International Conference. With the kind of enthusiasm and activities of the Indian Geotechnical Society and its members, I look forward to a much more greater role for IGS in the international community.
The Golden Jubilee Conference was held in 1998 at Delhi. IGC has hosted the council meeting of ISS-MGE at Bangalore and the 6th Asian Young Geotechnical Engineers Conference very successfully, thanks to great efforts by Professor Sitaram, Professor Srinivas Murthy and the team. IGS was successful in bidding for the 6th International Conference on Environmental Geotechniques to Delhi in 2010, which was a great success with due to Professor Manoj Datta's great efforts. The international community has become aware of our true potential, with several of our members becoming active in several technical committees of ISS-MGE. IGS has a full-fledged office in New Delhi, catering to the needs of its members. IGS publishes a quarterly journal since 1962. It is now accessible online to all IGS members free of cost. Since 2012, the journal is being published by Springer for qualitative improvement and international reach. It has wide circulation and is retrieved internationally. IGS also publishes a quarterly newsletter to keep its members abreast of all geotechnical events. IGS operates through its local chapters that keeps its flag high in different cities of India. With 44 active chapters, IGS has spread its reach to every part of the country. Some of the active local chapters include Delhi, Roorkee, Mumbai, Indore, Pune, Goa, Surat, Bangalore, Chennai, Kolkata, Guwahati, and several others. To encourage the chapters, an annual Best Chapter Award was instituted in 1995. The Delhi chapter has won this award a record 5 times. The geotechnical industry in India is incomplete without its partnerships with geologists, earth retention system contractors, consultants, and public sector organizations. Institutions like the IITs, CSMRS, CRRI, CBRI provide industry-academia interaction so that the benefits of research reaches the industry and the industry can input to the academia what the thrust of the research should be. This helps in directly applying the findings of the research on the ground for real implementation. With the growing demand for land, we have skyscrapers sprouting up in every big and small city in India. As industries grow, demand for power and power plants also increases. Connecting the industries through bridges, highways, railways, and metros, the Indian geotechnical landscape only shows a promising future. This also means that there is a demand for quality work as the margin for error is nil. Today, IGS is working towards setting up a joint assessment for testing soils along with the National Accreditation Board for Laboratories, the NABL, to match the quality of testing with the international standards. IGS is also working with the Bureau of Indian Standards to prepare Indian standard codes in several aspects of foundation design and field and laboratory testing. Many of our members serve in these committees.
The future is very bright and full of optimism. A number of initiatives have been taken up, promotion of student chapters in various colleges and institutes to sensitize the students about the importance of geotechnical engineering in the curriculum and the practice. Creation of number of professional groups to make them aware of the future challenges and opportunities in geotechnical engineering. A number of initiatives such as interactions with other professional groups that are overlapping with geotechnical practice are also initiated. It's hoped that with all these initiatives and further initiatives that one can have at IGS level, there could be better geotechnics in the country, which ultimately to better, cleaner, sustainable societies.
The future of geotechnical engineering lies in the hands of today's students. Recognizing this, IGS has set up student chapters in some cities, several more in the offing. As we celebrate the 70th year of the Indian Geotechnical Society, the possibilities that we look forward to are limitless. Here's to saluting the past, celebrating the present, and welcoming the future.
Thank you all for the patience listening. It has been all the efforts of this great person who have led to elevation of the entire IGS community. So with this, I'll hand over the stage to Dr. Ashok Kumar Gupta to please share a few words with us.
Honorable Vice Chancellor, sir, my faculty friends here, the members of our IGS chapter here, I thank current President Dr. Anil Joseph for giving his valuable time here. I thank Professor Samadia. Myself, Professor Samadia and Professor S.K. Jain share the same guru, Professor Bhavani Singh. And I did MTech with Professor Bhavani Singh. when I was Roorkee from 84 to 80 to 86, I have done my BE and ME both in civil engineering from IIT Roorkee and did PhD from IIT Delhi. And this chapter was landed here due to the effort of IIT Roorkee only. Professor S.K. Jain was in a habit of going to Roorkee and Delhi always. He will meet Professor Vilatkar and Professor Bhavani Singh there. He will meet in Delhi his friend in CSMRS. And they forced us to bring a chapter here in Himachal. There was no chapter. So this was the background of this chapter. So we are doing activity here with the help of our central body. I thank everybody for joining this inaugural session. And Neeraj Pariyar, in his own speed, is doing a lot of good work here. But he will always try to do excellent work. When he was doing his PhD, I asked 2 years back, okay, you submit your PhD? No, sir. I will submit my PhD when I finish all the work. And he has not listened to his guide, to submit his thesis early. So he do work at his own space always. So that is the liberty given to him, but he will do always nicely. Thank you so much for joining this program. Good luck. Thank you so much.
Thank you, sir. Thank you very much for your kind words. Now I'd like to invite Professor Ashish Kumar, HOD Civil Department, to kindly share a few words with us.
Thanks, Neeraj. Professor R.K. Sharma, Vice Chancellor, Jaypee University. Professor Ashok Gupta, Dean Academic and Research, and also he is Chairman of IGS Chapter, Shimla. Dr. Anil Joshapji, who is MD Geostructurals Pvt Limited and presently President of IGS. Dr. AP Singh, Secretary IGS. Samadhya sir. My colleagues and dear participants, good morning to all of you, and on behalf of Department of Civil Engineering, I welcome you all in this webinar series, that is the Advances in Geotechnical Engineering. So basically, basic objective of this type of conducting lecture series is to provide exposure and share work amongst the civil engineering community about the new innovation practices and techniques that is currently going on in the field of civil engineering. And specifically, if we talk about this webinar series, that is basically focusing on the geotechnical engineering. So my strong belief that we all will be benefited from this lecture series, and there will be good discussions and sharing of thoughts among this civil engineering community. My special thanks to IGS who provided us support to conduct this webinar series, and my special thanks to speakers also that they have given this. They will be providing some insights in the field of geotechnical engineering, and they agreed to be a part of this webinar series in a short interval of or short notice of time. Many thanks to all of you, and over to you. So once again, I thanks to all of you. Over to you, Neeraj.
Thank you, sir. Thank you very much. Now I'd like to request Dr. Anil Joseph to please take the stage and kindly inspire us with his words.
Yeah, very good morning, all of you. And first of all, I would like to thank Rajendra Kumar Samasa, the Vice Chancellor of University, for inviting us to Shimla, to the university. We have not visited it. Definitely in the next opportunity, all three of us, myself, AP Singh and Samadhya sir, will be there together, and we will have a physical program in the near future. And also that I am very happy that IGS Shimla chapter is back into life after a short gap. And thank you, Ashok Gupta sir, the IGS chairman there, and the lead behind the formation of the chapter there, to initiating this process. Let us keep doing this, because knowledge dissemination, especially in the field of geotechnical engineering, is a very vital aspect. Ashish Kumar sir, HOD, thank you very much for this initiation of opening that. And I would like to thank AP Singh, our secretary, who has joined in, and my predecessor Samadhya sir to be here. Indeed, geotechnical engineering is a subject, and as the father of soil mechanics, Carl Tersaghi, pointed out, it varies horizontally as well as vertically, and it is more of an art than a defined science. So since it's an artistic component, it is not a defined engineering, and we need to discuss it problem, and unfortunately it is all buried below, and it brings in surprises. So there were a lot of impact which happened last monsoon, especially in Himachal Pradesh, where many structures has caved in and the foundations has failed. We had the tragedy at Joshimath, where more than 760 buildings has to be demolished after the problem. So after that, Government of India has taken special interest. A committee was formed, and in the revision of the National Building Code, where I represent Indian Geotechnical Society, now we have come up with a situation that any building more than 15 meter coming in any part of India should have a geotechnical investigation report, and all the foundation drawings should be signed by a geotechnical engineer to ensure the safety. And in hilly areas like Himachal Pradesh, we have suggested that any building more than 2 floors or more than 1 floor should have a geotechnical investigation, but it has not yet come in the draft. But we are asking that hilly area and sensitive terrains, we have to come up with clause also, so that the accountability is to be there. Because when we look at the tragedy after Joshimath, when the team investigated, they were not able to get a good soil investigation report. The buildings has got sanction of 2 floors, and they have constructed 8 floors. So there is a policing needed, a good engineering. We know we have good engineers in the country. There is a abundant, wealthy knowledge of a huge wealth of knowledge is available, but it has to be given into the society where it matters. And engineering is the art of applying knowledge into practice, and geotechnical engineers has to play a very vital role for the safety of the structures. So we are adding our 2 cents to that. We need the support of you people also from the academic who has got a lot of knowledge. So we will try to bring together, educate the society so that these rules don't just lie in the paper or in the National Building Code. It become part of the activity, and the safety of the structures are ensured, and it is a very vital phenomena. And again, I would like to thank Neeraj Singh, who has taken all this effort to bring all of us together. And next time, Neeraj, it should be a physical meeting where we will all come over there. And I congratulate the Jaypee University for taking the initiative. IGS Shimla chapter in particular also. And then you should also associate with IIT Mandi and team to bring all together, so that the Shimla chapter become very strong. And there are so many good colleges there. And even I am the chairman of the Civil Division Board of the Institution of Engineers India. And I have seen that the Institution of Engineers India is very vibrant in the state of Himachal Pradesh, and especially in its Solan area, where we have a very good team there. A lot of activities keep happening to improve the knowledge. And there you need a lot of geotechnical and structural problems are there which need solution. And as people in the industry, let us try to contribute and make sure that we create safe structures for the future of the country. And thank you very much for the opportunity. And I wish all the very best for this webinar. And let us keep continuing spreading knowledge so that it benefits the society in the long run. Thanks a lot.
Thank you, sir. Thank you, sir, for inspiring words. Definitely we'll be in touch in the near future as well. And you're always welcome for a physical meeting with us, and we'll love to do that. Now, moving forward, I'll request Dr. AP Singh, Secretary IGS, to please share a few words with us.
Honorable Professor R.K. Sharma, sir, VC JUIT, Dr. Anil Joseph, President, Indian Geotechnical Society, our ex-president and my teacher, Professor N.K. Samadhiya, sir, thank you for attending the inaugural program. Professor Ashok Kumar Gupta, sir, Dean Academics Research, JUIT and Chairman IGS Local Chapter, Shimla Chapter. Ashish Kumar Gupta, sir, HOD, and Neeraj Singh for conducting and being the main source of organizing this program, entire webinar series in the for the local chapter. So good morning, and I congratulate to the entire team of IGS Shimla chapter and JUIT for carrying out the torch, being the torch bearer of geotechnical fraternity and geotechnical engineering. And when the reference of Himalaya and development of Himalaya comes, two prominent peoples come in our mind. First is Civil Engineering Department, University of Roorkee. Now it is IIT Roorkee. Along with this, Professor Bhavani Singh sir, Samadia sir, and his 11 prominent students whom he created, who did PhD under them, and now they are the torchbearer of rock mechanics and entire development in Himalayas. Second name comes Jayprakash Gaur. If we see the history, a lot of powerhouses, dams, first dam at Haridwar, Rishikesh, that was constructed by Jaypee Group, Jaypee Industries, and a lot of contribution he has made for the growth and development of Himalayas. And if we see the nature of Himalaya, JUIT is very well blessed that you are sitting on the huge laboratory of rock mechanics and in that Himalaya. So it's a big responsibility and challenge to JUIT. And I'm very happy after 3 years, during the COVID time, a lot of webinars were organized by JUIT. Even Neeraj was very active, but due to maybe some regions, this gap came and now it has been started. So congratulations to the entire team of JUIT and IGS local chapter. And certainly whenever Neeraj calls, we will be there physically along with Samadia sir and Anil Joseph sir. So I hope and I wish very best for the success of this webinar series. So thank you very much for this.
Thank you, sir. Thank you very much. We'll be eager to have a combined meeting with you as well. Now, with your kind permission, can we just move on to the main part of the lecture series?
Neeraj,
Samadia sir.
Samadia sir, so you should request.
Yeah.
Sir,
please, I request you to speak something.
Please, sir. Please.
A very good morning to all of you and
morning,
all
sir.
who are attending this inaugural function. And thank you so much, Neeraj, for inviting me to be part of this function also, and also the lecture series. And after seeing the video of your university, I am thinking, why have I not visited JUIT so far? Why did I? Because I have gone to Shimla several times, but whenever I have gone to Shimla, it was for some project related to project. So because of the paucity of time, I could not visit it, but I promise in near future, I will definitely like to visit JUIT. As far as the association of IIT Roorkee or University of Roorkee is concerned with JUIT, long back, as Professor Ashok Gupta has said, that he has completed his BE and also ME, and he belongs to the same group to which I joined in 1990. So in that way, I am junior to you because we are from. But whenever Professor S.K. Jain, actually he was, when he came back from USA, he joined this JUIT. And I kept on interacting with him on several issues, maybe the academic or non-academic. And I think he has organized a very good conference on critical state of soil mechanics. And but somehow I could not visit, so I feel really sorry. I regret it, but definitely in future I will come. And as far as the support of IGS is concerned, under the leadership of Dr. Anil Joseph, we are progressing very well. And in near future, we will be having more activities, especially in Northern India, because if you are aware that 2025 IGC is given to NIT Jalandhar, and this is the first time in the history of Indian Geotechnical Society that the conference has gone up geographically. We have organized in Roorkee several times, but beyond Roorkee, it has not moved up. So the executive committee was so generous that we requested that we should give at least Northern India the opportunity. So Shimla chapter is also in queue. Everybody would like to come to Shimla. So Neeraj is doing well. Thank you so much again, and best of luck for this particular program.
Thank you, sir. Thank you very much. This has been really very inspiring. Surely we'll call you sometime whenever you are free, and maybe we can sort out a common time between us, whatever is suitable. And definitely we'd love to have a meet with all of you. So with this, can we move to the next part of the session?
Sure.
Okay. So thank you to all the guest speakers for today. And before we could start today's lecture, let me give a little introduction about our today's speaker, who is also the IGS president, Dr. Anil Joseph. So Dr. Anil Joseph was awarded PhD from NIT Calicut on his work on pre-compression of soft marine clays. He is currently the managing director of Geostructurals Pvt Limited, a leading foundation and structural consultancy firm based at Cochin. He has provided foundation and structural consultancy for more than 3,000 high-rise structures, including many landmark multi-storied and infrastructure projects in India and abroad in the last 30 years. His marvelous designs of Nippon Toyota showroom at Kalamassery, Platinum Mall at Maradu, Lulu Grand Hyatt Hotel and Convention Center, Bolgeti Island, Kochi has won the ICI Ultratech Award for Outstanding Concrete Structures of Kerala in the building category in the year 2012, 2017, and then 2018 respectively. He is also currently the managing director of Sequence Private Limited, a construction firm specialized in the execution of pile foundations, and also the director of Engineers Diagnostic Center Private Limited, a firm specialized in the geotechnical investigation and retrofitting works. Dr. Joseph is the current president for the year 2023 and 24 for the IGS, National Council member of Institution of Engineers India in the Civil Divisions for the term 2021 to 24, and chairman of the IEI Civil Division Board for 2024. He is also the governing council member of Indian Association of Structural Engineers and the chairman of Indian Concrete Institute Kochi Center and vice chairman of the Builders Association of India of the Kochi chapter. Besides, he is also representing India in the International Technical Committee TC220 in the field monitoring in geomechanics and in the Asian Technical Committee ASRTC 14 on smart observation methods. He is the immediate past president of the Association of Structural and Geotechnical Consultants, Kerala, immediate past state president of the Graduate Association of Civil Engineers, the past president of the Association of Piling Specialists, Kerala, the member of Association of Contracting Engineers, executive committee member of the Foundation Institute India, managing committee member of Kerala Management Association, and an adjunct faculty of the Albertian Institute of Science and Technology, TOCH Institute of Science and Technology, Cochin, and Federal Institute of Science and Technology in Angamali. He was also part of some of the other marked events in the construction sector, such as when it was decided to raise the 5 high-rise structures at Maradu in Cochin as per the direction of the Supreme Court. Dr. Anil Joseph was appointed as the geotechnical and the structural expert in the technical committee by the government of Kerala in 2019. He also played a vital role in the demolition of the famous Supertech Twin Towers in Noida in August 2022. So these were some of the achievements of him. Besides, he had a dynamic social career as well as has been a part of the various social and sport establishments throughout. He was also one among the top 10 Diamond Hall of Fame New Age Icon Change Markers in 2020. So this was some of the introductory points about our speaker of the day. He's a brilliant speaker. I have heard to him a number of times, and that was the reason I have called him on this stage. With this, I'd like to hand over the stage to Dr. Anil Joseph and request him to please enlighten us with the inaugural lecture session. Over to you, sir.
Thank you, Neeraj. Thank you. It was a bit lengthy introduction, but thank you anyway. Thank you very much for that. One second, I will just get the.
Yes, sir. You may please share your screen now.
Yeah. Is it visible now?
Yes, sir. It is visible now.
Yeah, fine. So good morning once again, all. So, and I congratulate once again the organizers and for sharing this knowledge. And thank you very much for giving me this opportunity. So today I will discuss with you few stories about the foundation failures and primarily on forensic engineering and monitoring vibration impact during demolition of the structures. So these are all case studies, not much theory involved, but I always believe that we learn maximum from failures. So I will be covering today's talk in the following criteria in the next 45 minutes. So with an introduction on forensic geotechnical engineering, then a case study on the rectification of a tilted pier for metro. One second. Will be a rectification of a tilted pier for Kochi Metro, and then a forensic study of touch pile system failure for a commercial building and vibration impact during demolition, and also we'll talk upon something on the demolition of a new structure recently in Hyderabad for Reheja Group. And forensic civil engineering can be considered to be the it's just like a postmortem. When a failure that happens, they do the analysis, doctors do the analysis and find out what is the root cause. Similarly, when a failure happens, engineers has to understand what has gone wrong and find out what is the reason. And always your maximum knowledge can happen from the failures, and we have to learn from how it happened, and we have to share this knowledge so that it doesn't get repeated, especially when in the area of foundation where so much of uncertainties are associated. So
sorry to interrupt, sir, but it's not in the full screen mode.
One second.
Yes, sir, now it's fine. Now it's fine.
Okay, fine. Yeah. So whenever you do deep excavation, there is always this challenging, and always remember that, because now what is happening, the buildings are going taller and taller, and the basements, because of the services, car park and all, we need to go down deeper and deeper, and it is becoming very common now to go for 3 basement, 4 basements, etc. So deep excavation is a technique where we must take into account the interrelation between soil structure interaction and construction technique, as well as the effect of construction on adjacent environment. And as Madhav sir first pointed out, that it is more comfortable when you deal with steel. Concrete is more trickier because again the water cement ratio is a vital part. But moment you get into soil, it's totally a different ball game, and we have to be very careful in our judgment, and we have to understand its behavior properly before we come up with the adequate need of the foundation. And Saxena has always said that a practicing geotechnical engineer should always fear the lawsuit, and he has to ensure that his details are presented well and the uncertainties are also highlighted when he come to a conclusion. So with this, let me take you to this first case study of the rectification of a tilted pier of Kochi Metro, that was pillar number 347, and this is the beautiful city of Cochin. So from Himalayas, I request all of you to come to my hometown, which is Kochi, and we have a lot of water metros there, and we have a beautiful harbor there, and backwaters cruises, and it's a very beautiful city, and is known as the Queen of Arabian Sea. So I request all the team members from the Jaypee Institute and the students also to take this, whenever you get an opportunity to come to Kerala, do come and visit this beautiful city in the southernmost tip of the country. And this, according, if you look into the story of this Kochi Metro project, it was this is first metro in the country which connects rail, road, and water. So we have a water metro also. So you can get in down there and then move to water metro and travel across. So Prime Minister Manmohan Singh did the stone laying in 2012. Work started in 2013, and our Prime Minister Narendra Modi ji inaugurated it on 17 June 2017. So this was the historical background. Now this was the phase 1 of the project. Everything was fine. It was going on, but recently what happened that whenever these drivers were driving through, they started hearing the variation in the sound when they were moving over a pillar number 347. So they discussed among themselves, and it was put into the authority that there is some sound changes when the train runs over that. So an investigation committee was formed. They looked into it, and they found that there is a slight tilt happening in the pier cap level. Then when they checked it up, a further investigation team was formed, and we found that the pier is also tilting. And on further study, we found that the pile cap is also undergoing tilting, and the pile is moving down. So this was a big challenge. The train was running, and we have to come up with a solution to the problem. So this was what happened. That was in Pathadipalan near Edapalli, and minor gap between viaduct and track was spotted. And there was no defects found on track and viaduct during inspection. And again, as pointed, slight tilt was noted, and then all the concerned agencies worked together, and we found out how to come up with the solution. We had a discussion. So we decided to slow down the speed of the train from 35 kilometers per hour to 25 kilometers per hour. And in the meeting, the discussion came up, and I was also called in as an expert to look into the matter. And we have suggested that let us stop the train running. But then on further discussion with the team, we had an MD who doesn't have anything to do with construction. He was a past DGP, an IPS officer, DGP of the state. And when we presented the case, he told that no, we should not stop the metro running. So we had a sketch, and we found out the tilting is happening to one side. So he suggested that whichever is not tilting, we'll allow the vehicle to train to travel through that at slow speed, so that it is not totally stopped. And then we will go for rectification work. So this is the investigation. So when a failure happens, we find out, we reinvestigate and found what is the root cause. So the investigation was found, and suddenly it is revealed that this particular valley had very soft clay on the top, and suddenly the hard rock strata comes up. So the entire thing was carried out, and again there was a confusion that whether the hard rock is continuous or not. So there was a 5-meter drilling into the hard rock to work out the core recovery, rock mass, and other aspects to work out and ensure that there is no boulder formation at the bottom. So which was carried out and proved that there is a continuous rock strata. Then we started investigating what has gone wrong, how it was done, and what is the reason why this failure has happened. So we found out that by doing pile integrity test, that the contact, there is a softer formation at the bottom tip of the pile. So what happens is that when you do the pile, when you reach the rock and allow that, because there is a soft clay on the top, so we provide liner only on the top. A steel casing will be on the top, and it is supported by bentonite circulation or a polymer circulation towards the bottom. And what happened that when you went through the records and studied, all these piles were completed, terminated, reached the rock strata, but then due to some strikes which was happening, material shortage was happening. Concrete was done after about 72 hours, and it was done late night around 3 o'clock. One pile was casted on the same day when it reached rock, and there was no movement happening. It was seated on that. And on the other cases, all the other 3 cases, there was a huge softer formation which happened, and that side was going down, and the tilting was happening because of this problem. So and why it has happened suddenly? Because there was a heavy flooding which happened in the previous season, and due to this imposed loading, the frictional component has totally gone, and the soil started pressing into the softer formation. So this everything was studied in detail. So we have to come up with now, as a forensic investigation, we found out what is the reason for that, and now we have to come up with solution. So the trains are running on the top, we cannot change, dismantle everything. So we decided to underpin the tilting pier cap and the foundation. So we went in for additional 4 numbers of pile was provided, and underpinning was carried out. So here you can see that myself guiding the team, and we cannot bring in big hydraulic machines because already the trains are running on top and we cannot disturb the system. So this was monitored, a 24/7 monitoring mechanism was done. The work was carried out, and specialized equipments like chiseling systems and breaking the rock to get 1.5 meter anchorage using hydraulic drill systems was also implemented. The work was progressing slowly, and the integrity test was conducted. Now here in this picture you can see the additional pile getting done, and we are anchoring using Hilti anchors, high strength Hilti anchors. About 1,400 rods were anchored into the old pile cap to connect it together with the new thing. And now we can see here the old pile cap there, and now the new pile cap where the loads will get transferred, and strong structural systems were also made so that the load get bypassed from the other thing to the new pile system. And in order to prevent the damage, this time we have taken the casing down to the bottom up to the rock and ensure that there is no site collapse happening, and the concreting is done immediately. So the entire work was completed. The train was successfully, the entire thing was observed, and we found that everything has become stable, and now we are able to successfully get the lines running, and both the metros are running parallelly, and it's all solved, and it's also being continuously monitored now also to understand the observation. This was done in the last year. So this was my first story. And my second story again deal with a failure of a touch pile system for a commercial building at Cochin. And again, if we come to Cochin, you can hear some of the world's best cruises comes and visit us. And we have a very beautiful natural harbor. So this is protected, so we don't need any breakwater structures. And this is where the city is. This is the natural protection, and we have a huge LNG terminal here. And we have a beautiful Dubai port project here with the container terminal there. And this is the LNG terminal, and the ships comes in through and sails into our harbor. So these are all the shipping facilities available. And we have a lot of fishing net. This is that called Chinese fishing net, where a lot of fishing is one of the major industry here. So this story is of a commercial building having 3 basement, ground and 8 floors. And in this they had parking floors at basement, ground, and 2 basement they had parking, and 7 and 8 was parking, and the other areas was commercial floor. So they have to excavate to a depth of 9.5 meter, and this was the location of the project. And in order to make this excavation going up to about 10 meter, they had 337 piles of 90 centimeter diameter going to a depth of 30 meter. And also they have provided 28 soldier piles of 600 mm diameter to a depth of 30 meter. Building piles were taken to a very dense sand strata at a depth of 43 to 46 meter. And why we have gone for this touch pile with a propped system? Because once you have a cantilever, it is WL square by 2. Moment you have a propping at the top, it become WL square by 8. Or it's a propped cantilever, bending moments comes drastically down. And the soldier pile is to economize the design of the strutting systems, because when the span gets controlled with the soldier pile as a support in between, so that the section can be optimized. So these are the application of the knowledge of basic engineering into the field. So the work was carried out there. So phase 1, they have gone up to 2 meter. Phase 2, they went up to 6.5 meter. And phase 3, they went up to 9.5 meter. And here you can see a video when the work is going on. So this is at 5:30 in the evening. So you can see that the work is here is the touch pile systems all in place. This is the strutting system. This is the soldier pile, and work is going on in full-fledged. So by about 7 o'clock, there was a slight movement, and the wall has started creaking, sounds has started happening. The engineer in charge was a very young, dynamic engineer, so he immediately informed the district disaster management team headed by the district collector that such a problem is happening in this site. And I was I was representing the district disaster management as the engineer, structural engineer, and foundation engineering expert. And I was asked by the district collector to go and have a look. So by the time we reached there by 8 o'clock, we see that there are about 20 to 30 people working below and trying to provide support to the structure. And immediately we asked to evacuate those people. And by 9 o'clock, this is what happened. So if you can see this, so here you can see that as the thrust become higher from the retaining wall, it started pushing, and the soldier pile got sheared off, and the strutting system failed. So suddenly movement jumped, and the failure has happened. So this is what happened, and this is the write-up of that. And the 9:30 p.m. the entire thing came down suddenly, and this is the photo next day morning, and you can see this red building. The foundation of it has exposed, and building started tilting towards this side. So this is the touch pile system which was there. The entire thing has collapsed. So here, if you really see that, you can see the equipments lying down below. The strutting system failed, and we have to work out. The nearby road has gone down. It sunken slightly towards the side, and there were cracks totally. Electricity and water supply got disrupted. The roads got stuck, and the Kochi metro also came to a halt, because we have to analyze what went wrong before allowing the traffic to move on. And again, a committee was formed to find out what is the reason of collapse of touch pile system, whether they have satisfactorily done the statutory government approval, and whether we will be able to do the construction using this touch pile system again. So these were the steps taken by the district management committee, and I was taking the structural engineering lead role in that. So we rerouted the public traffic, refilled the excavated area, 2-layer sheet piles were provided, and filling of inner side of sheet pile to counter the lateral force, because once it is 10-meter cantilever, it is WH cube by 6, and if we can fill it by 5 meter, then it is much safer. And to conduct the core test and integrity test was carried out to find out what is the root cause, and to rework the road and bring it back, we went for coconut pile systems, and we made innovative geo cells formation to control the loading, and within 4 days we were able to get the road back on track, and additional soil investigation was carried out. So here you can see that the pile has come out, and the works are being coordinated. Here I am instructing the team how to go about, and here you can see that the double sheet piling system, and here is where the metro was running, and this is the refilling was done to control the pressure and to understand what has gone wrong. So this is the double layer sheet piling system, braced and covered with, you can see that the pore pressure dissipation system was provided, and water was drained out in order to prevent the damage. And then we went for concrete core test, pile integrity test, additional soil investigation, and then all these data were corrected, and then we went for geotechnical and structural analysis using Plaxis and STAD models to work out what was the root cause of the problem. So here, this is the integrity, core, and soil test happening, and we found that again the strength of the concrete was good, the depth of the pile was 30 meter, and what went wrong in the integrity test pointed out that the pile was sheared at a depth of 14.5 to 15 meter depth. So here you can see that, thanks to geodynamics team led by Ravi Kiran, who supported me in this testing process. And this is the soil report, and the design was studied, in depth analysis model, and what was the capacity was worked out. So we found that this 90 centimeter dia pile going to 30 meter with the reinforcement provided can take the capacity of 815 kilonewton per meter. Then we did a modeling on different cases, because we have to convince the authorities also what went wrong. So 5 meter retention, what happened, 6, 7.5, 9.5, various case studies was done. 5 meter, we found it is the factor of safety is quite good, there is no problem. 6 meter still is a temporary structure, factor of safety of 1.3 is there. And once to move to 7.5 meter, the touch pile alone cannot take care. So we should have the strutting system and the soldier pile working to control the system. So this was the strutting system. And this is the three-dimensional model with the springs formed to stimulate. And this is the utility ratio of the truss elements worked out. And we found that at 7.5 meter, it also nearing this thing. And once we move to 9.5 meter, we found that the moments are much higher. The strutting systems was a bit inadequate to handle that. But then, so here you can see that these are the soldier pile. This is the strutting system was modeled and analyzed. And we found that what happened was that the strut system was not inadequate enough. The soft soil has yielded and liquefaction has happened. And the point of fulcrum in the design, they have assumed that after 10 meter, there is a fixity. It has moved down to 14 to 15 meter. And the moments jumped drastically. And that was the major reason for the collapse, leading to increased supported length. And a second tier of strut system at lower depth could have prevented this. So the analysis was carried out, diagonal cross bracings was suggested, and we asked to move it back by another 5 meter. And we have given them permission with the second tier of strutting to carry out the work and complete the process. So it was just sheer luck and timely interruption that there was no loss of human life. And there was only one building which has to be dismantled because its foundation got exposed and it got tilted. And everything was carried out. The rework was done with total instrumentation and monitoring, and the entire thing is completed, and the work is opened and is ready, is functioning right now as a textile showroom. So here you can see the metro also. So now coming to the third story of monitoring vibration impact during high-rise demolition, and we'll take you to Delhi for the story of the Supertech Twin Tower Noida, where in my career, I have been a structural engineer primarily, and more than a geotechnical engineer, where I have done more than 3,500 high-rise structure. And where there were the few stories where I have to become the demolition expert also to get the building down. So I talk about this concept of implosion, where we keep sensitive explosive material in the vertical supports of columns and shear wall and explodes it so that the buildings comes down the way we want. So if you say the stages of demolition, it comprises of surveying the area, study the building plan, remove toxic material, remove non-load bearing wall to control the impact happening in the ground, drill holes in column, and do the explosion. So this is the theory. And let's see a couple of videos. What is the challenges involved in that?
The enclosure dominates tonight's special edition of Geotechnical News. We begin with the disastrous aftermath of yesterday's implosion. It's estimated a crowd of 100,000 people lined later to witness history. What followed will be etched in the memories of us all for years to come. Organisers had intended yesterday's demolition to be spectacular. They couldn't have imagined the traumatic effects it would have on the national capital. Instead of a contained implosion, boats on the lake and crowds on the other shore were showered with debris. Shards of steel warped and twisted by the force of the blast. A 12-year-old girl was hit and instantly killed. No one was taken to hospital with minor injuries. Even today, no one could tell why the implosion turned into an explosion. It was a very painstaking and detailed investigation by the police. It's largely a matter, as you appreciate, I guess, of structural engineering questions, questions of physics, to determine the cause of the fatality and the implosion. The girl was killed 480 metres from the demolition site, nearly 10 times the prescribed safe distance set down by contractors. But today, witnesses gave graphic accounts of huge chunks of steel thrown far further than that.
So there was the case study. Hope it was clear. Audio was visible also, and the voice was clear. Video was visible and audio was clear. So this was the case study which happened in Canberra, where due to the implosion happened, it turned into an explosion, and a girl was killed about half a kilometer away over across the river, and there were almost 15 people injured as far away as 1.5 kilometers away. So, let's see this video. So this happened in Russia, where they tried to control, and this time they didn't put enough implosive material. So instead of an explosion, it was a failed damage which happened, and the building stood there. It didn't fail. And I am working for the second project of Supertech in Noida for a team called Jet Demolition from South Africa. And our team leader Joe Brickman always tell that if you don't do your engineering properly, the building will stand there and laugh at you. So that is exactly what happened in Russia. Let's see a couple of more failures before we see a couple of success and what we did in Delhi. So these were the different failures which was studied. And again, I emphasize the point, it is from the failures that you learn more. So when you have to do something new, challenging, because I never had an experience of doing demolition. But then in the 4 months when I was appointed by government of Kerala as per direction of Supreme Court to be the technical expert on that, 4 months we learned so much, that how the technology works, had interaction with this team from South Africa who was the contractor, and we went out to demolish this building. And the tragedy is that I was the structural engineer who designed this building, and way back in 2007 there were about 5 buildings similar to this, and we had about 367 families staying there. And after the construction was going to a particular level, it was found that it has not followed the new rule which has come up as part of the coastal regulation zone criteria. So all these 5 buildings has to be demolished, and government appointed me to demolish the buildings which I have designed about 14 years back. So let's see this video. This was the first building called H2O, where we have to do the demolition. So this is another case where we did the demolition of a 17-story building. And the adjacent building is just 7 meters away, and this water is at 5 meters. And without damaging everything, we were successfully able to complete it down, bring it down. So you can see from the video that water is just 5 meters away, and very little material has fallen into water, and there is no damage to the surroundings. So this was what happened in Cochin, where I learned this. And when they got this job, they asked me to be part of the team of jet demolition from South Africa. This time Supreme Court directly appointed them, and I was part of the team when we went on to demolish this 7 lakh square feet building comprising of 915 flats and 21 shops. There was in Noida, sector 99, and this is 93. And here you can see that this was surrounded by buildings across. So these towers, which is 12 floors, is only 9 meters away. And we have to bring this 110-meter tall building, 103-meter tall building without getting any damage to the surrounding. And to make it more challenging, we had a gale pipeline which is passing through the property. So we cannot stop this. So we have to control it and get the blast done. And why it was to be blasted? Because when they had gone for the construction with the same builder who constructed the nearby building also, he has sold this, he has given this area as a park, but later on he converted it and made into a building. And first they made it 9-story building, 12, and later on he got permission up to 40 floors, and they constructed up to 32 floors. So this is where the Gale gas pipeline was there. So we had the challenge. So we made the protection with steel plates. Then the berm was provided, geotextile were provided, and cushions were made with rubber tires to prevent the impact happening. And everywhere the densely populated area, all the challenges points were done. And now this is the second largest building in the world, which is demolished using this implosion technology. And to do this implosion, we took about 9 seconds time. In the 9 seconds time, we demolished the property of Supertech Twin Tower worth 500 crores. But for that 9 seconds of operation, we did 6 months of engineering. So right from the work was given to us in February. So I used to go to Delhi once a month. Then after a few months, it was twice a month. Then towards the end, I was camping there for 10-15 days to make sure that everything is going. So real engineering happens in the field. And here you can see that this is the inclination and the angle where we go for blast. So this is 0.5 seconds, this will blast. So it is staggered horizontally as well as vertically, 1.2 and 5.7 and another 3.3 seconds for the building to come down. So these are the primary and secondary floors. So in secondary floors, we blast only the shear wall, and primary, we blast all the column and allow it to fall in the particular angle where the space is available so that it will come down. So this was the challenges, and this is the different technologies which was adopted. This is the Sian Tower, and this is the Apex Tower. So it had about 41,720 tons of material, and the other had 18,150 tons of material. And it is not only that you do the implosion and get the building down, but we have to make sure that the surrounding building is safe. So we do pre and post blast survey, and rapid visual assessment of all the structures was carried out. So the entire preparation was monitored. So here you can see that everything is measured, monitored, and this entire thing built apartments, which is about 200 and odd number, which is marked in this yellow color. Every wall was measured, recorded, crack meters were provided, videos were taken and submitted to High Court of Kerala. And thanks to CBRI was appointed by the Supreme Court to be part of that. The way I was representing Government of Kerala in the 2020 blast, this time we had CBRI checking our design and verifying all the documents which we are submitting from the engineering perspective. So every wall, every cracks was monitored, measured, and put it into record. And also I insisted on having the current strength of that by going for NDT testing, such as rebound hammer, pulse velocity, and all records were made and submitted to court before the blast. And after the blast was completed, we did the resurvey to assess what was the damage. And in case to prevent any damage happening, the entire area was insured for 125 crores. So this is the three-dimensional modeling using the ETAP software. So where everything was stimulated. This is the vibration module was stimulated, and this is the three-dimensional model which you are seeing. And it was created, and different load condition it was modeled in, including the blast load, to understand how the behavior is going to happen. So here you can see this video, how the behavior is happening and how the building is oscillating under the impacts which is happening during an earthquake in this case. And when we move to this video, where how the blast is going to affect, and we have to ensure that the structures are safe during that process. So here you can see that the buildings are moving, what is the effect, and we compared with the earthquake modeling. And also you have to do stage-wise analysis, because we are ripping the building, so you have to ensure that the building is safe, all the different process, even if an earthquake come and hit the building during the time of the operation where you are doing the preparatory work. So that was also carried out. That's why it took almost 6 months of engineering to do the job, and everything was stimulated. And as per the code, we proved that it is safe. And it is very simple. If you can work out if the impact you can control to less than 3.5 centimeter per second, there won't be any damage. And if it is more than 11.5 centimeter, the entire surrounding building will have heavy damages. So I would like to thank the team from IIT Madras, headed by Professor Bhuminathan, who was part of the team to measure the vibration impact. So we had accelerometers, geophones, all spread across the area, picking all the data when exactly what is going to happen. So we have to evacuate about 5,000 people about 3,000 cars, 300 beds, and we had about 40 ambulances ready and 400-bed hospitals ready, so that in the case of an eventuality, the emergency has to be put into operation. And we have a team of about 2,000 police people and 20 fire engines ready in case something goes wrong in the planning, the operation of 9 seconds operation. So here you can see the points where the vibrations were measured. So thanks to the team from IIT Madras, who was in charge of doing the measuring and monitoring, and accelerometer, geophones, everything was measured, including Gale case pipeline was monitored continuously during the process. And for our this thing, so this is what happens exactly during when the blast is happening. So these are the controls. So all the vibrations were well within the permissible limit. It was all monitored, measured, and rechecking was done. Not much damage happened to the surrounding. It was a 99.4% blast. A perfect blast, where we had a small problem of a compound wall collapsing and 4 trees we lost. So that was the only damage which happened. So this was that demolition day, 28th August 2022, and at 2:30 p.m. as per the direction of the Supreme Court, we went for the blast, and this is what we did. So this is that before the buildings were there, it is no longer there, it is gone. So the entire debris were recycled, and then steels were went for recycling again, and the entire work has been completed and handed over. So this is how we drill the hole and place the wires. It is a 2-layer protection wiring systems. This is Professor Bhuminathan and Ramnath, the DFI chairman, was part of the team for the demolition. So this is Joe Brickman and Kevin, the team people who are doing that. And we'll just take a look into a small, recently did blast in Hyderabad mine space, where we went for a redevelopment, because now the vertical growth is happening and the buildings are going upper and upper. So this was a 8-story building they have to demolish to come up with another 40-story building there. So this was a recent demolition. So I will just go through the same process was continued. All the buildings were monitored, measured, and we'll just look into the video where how we went for the blast and how it was same team. So this is Joe and myself, and Kevin and myself, the team who were doing the job. So let's see this video. So, with that, this is the last video I would just like to show. It's a video in Malayalam. So I would like to close with this message that the only place where success comes before work is in the dictionary. So keep working, and the engineering is all in the field. Make sure that you convert your knowledge, which is gained from the colleges, into the field and make a difference to the society. So I am open to any question and answer session, and thank you all for a patient hearing.
Thank you very much, sir, for that insightful lecture. And it is really very astounding to see how you people are managing to let these buildings go off the ground without disturbing the other buildings in the vicinity. That is a very careful job to do, really. So, with your kind permission, may I read out the questions and the queries in the chat box?
Sure.
Okay, so first question is from Mr. Abdul Rafi. Which company did the underpinning, and is it pure geotechnical failure?
Yeah, the work was carried out by a company called Sequence Private Limited in Cochin, and primarily it was a geotechnical failure because the rock socketing, the proper placement of pipe to rock was not happened, and that led to the failure. And L&D was also part of the team. It was actually L&D's work executed by Sequence for that.
Okay. The next question is from Rina James. Which geocells were used in this case?
So in fact, we wanted to get geocell. It was very time consuming. It needed 3 weeks to get it transported from Gujarat to Cochin. So actually what happened, we improvised. We bought wire meshes from the market, made it into sections, and cross sections were also made with different gauge of wire section. Then the rubbles were put into that, and again it was capped with wire meshes on the top, so that artificially geocells was created, because we wanted to place an order, and when it comes it was too delay, and within 4 days we completed the entire operation. So if I had gone for a concrete pile, it would take 28 days curing. So we went for coconut timber piles so that it can be done overnight. So that was done in 96 hours, and that was the main news on the newspaper, that the engineers did a great job to get the road back on track. So engineering is all about improvising your knowledge into the field and how to come up with solution. And then even layman can advise us to come up with the right solution at the time.
That's a very sustainable solution. Have you ever proposed that solution in the coming works also?
Yeah, depends upon that, because again the durability, long-term stay, because it was a temporary job, so we had gone for that. And to get the geocells, it was a big challenge. We talked to almost all these good people in the geotextile industry are our friends, but then they all had that lead time to bring the material because it was not readily available. So that is why we went for this improvisation of going for geocells.
Right. So let's go to the next question. It's from Ms. Nikita. What things are to be kept in consideration while deciding the depth of boreholes?
Yeah, that's a very good question. the depth, because based on the load which is going to come, and what is the strata going to, what is the strata available there, and what is the intensity of the scale of the project. It can be a feasibility study, it can be a pre-feasibility study, it can be a detailed engineering. And I always suggest that geotechnical investigation opens in the site. So if you do a investigation, you have a data. If you take a 4 borehole or a 5 borehole in a 1 acre of plot, your probability is 1 in 5 lakh, much higher than that. So whenever you do the opening, the good geotechnical engineer has to go to site and ensure that what is visible, because it opens up at that time, is something matches with this. So again, depth depends upon what is the strategy you need and what is the load you have to transfer. So for a small project, if the soil is weak, you have to go deeper. But if it's a very good strata, you know what is the bulb of pressure going to act. And within that range, if it is strong, you need not go into rock that much to ensure. But for major projects, we go 5 meter into hard rock to ensure its continuity.
Right. I think the problem, you have got the solution of the question that you have asked. Next question is from the Manish Kumar. What special measures can be taken in the case of dealing with boreholes in saturated and collapsible soils?
So we have to have proper lining to be done. In case needed, you have to go for casing, especially when we are doing with soft sensitive clay. Ensure that it is going down properly, and you should have a good mechanism to retrieve it back. Because certain cases where we do marine boreholes, we go up to 40 meter with casing. But we have systems to ensure that we have enough capacity to pull it back so that we are not losing the material. So that's a very tricky situation, because if you depend only on the bentonite circulation, or now with the environmental issues coming, we are now going for polymer circulation. So the stability of the borehole cannot be ensured. So we make sure that the casing is driven sufficiently deeper to prevent the collapse, so that we get accurate logging data.
Okay, thank you, sir. There is next question from Mr. Amanpreet. How do you ensure the minimum lateral swing of the building while demolition, like the building shown in the video?
Yeah, so we have to work out. So with the demolition, we analyze just like the structural analysis we saw in the ETAPS modeling. Everything is modeled in and stimulated, and to ensure that when we go for the blast, our trick is to allow the concrete to explode and steel to buckle, so that it comes as a soft landing on the ground, so that the vibration is controlled. So the swing and the angle is also decided based on, and that's the sequence of operation. Like just like cutting a tree, you cut this direction and you allow it to fall in that direction. So that sort of precision has been done in this entire process. And that is where we have a lot of teams. Like it's a team of 10 experts, 10 verticals we have, like electronics engineer, mining engineer, electrical engineer, so computer stimulator. So we all have this 10 people, and major role played by structural and geotechnical people. So that all team work together, and it's not one-man show. We have a team. So I was working below a South African lead head who has got about 300 experience of blasting. So I had only 8 to 9 projects which I have done. But since I was in India, it was more easy for me to handle that, since I was part of the Cochin demolition also. So that is how the team work. And the lateral swing we calculate, we stimulate it and model it how it's going to behave.
Okay, so that's a beforehand simulation that is going behind the screen also. Okay, the next question is from Ankit Desai. When you observe any failure, how do you decide, conclude, or investigate what is the cause of failure?
Yeah, first of all, there has to be an authority, because luckily now disaster management authority is prevalent all across the country. As engineers, I am a volunteer with them for maybe last 20 years. I am volunteering with them. So anything happens anywhere nearby, I am put in charge to do the job. So we demark the area. We didn't allow them to anyone to enter into those areas. We take photographs, records, and then we rework and we analyze what was the concrete, what is the actually you should be very clear. You should not be judgmental. You have to come to your conclusion based on the data you collect from the field and based on the documents and detail. And it's like an interrogative process. It took almost 2 months for us to come up with the report. You talk to the geotechnical engineer, structural engineer, architect, builder, the contractor, who has done and what was the reason. So with all this data collected, we stimulate, we make our own judgment and come to the conclusion that what is the root cause of the failure. And most importantly, what should be the solution to make it into a reality on a long time.
Thank you, sir. The next question is from Sivathan Sabisan. What sort of explosive used for those building demolition works?
Yeah, very good question. Actually, we wanted to get demolition from abroad when we started it in Cochin, but we found that government of India has lot of restriction, and we have a few explosive companies in Nagpur in India, from whom we have the Suntech was the company which has supplied for us. We get very good emulsions and explosive within India itself. So those were used in India because our abroad consultant wanted things from UK and this thing and South Africa, but then we have taken the decision to go with Indian products, and we have done the entire thing with Indian manufactured materials only, the explosives. But then you have to have that precaution how to handle it. So there are explosive experts now on that.
Right. Good to see we are into the Make in India now, in even in the field of explosive as well. Okay, and next question we have. As far as we could see in the video, the ground motion on nearby structures depends on the progressive collapse of the building. Was there an analytical study conducted to determine this load? What was the radius of such load considered depending on the soil conditions?
Yeah, so that for that particular job, we had the support of Vibrotech from UK, who is again a pioneer in the demolition of structures. They supported us in this case, where they analyze what is the load, what is the impact, and how we are going to hit the ground, and what is the behavior. So you can see that the ETAPS model base data for me to provide the lateral loading in the stimulation. This was provided by Vibroc with the intensity and the blast which we are providing. What is the impact going to hit the ground? Based on that, we stimulated that curves and modeled it into the ETAPS to come out what is the behavior going to happen. So that sort of homework has been done to before we generated the three-dimensional modeling.
All right. There is one more question from Aniket Desai. For any construction project, how to decide the number of boreholes required?
Again, depends upon the type of the project. So if it's a small project, you need a minimum 1 borehole or 4 trial pits, or like they generally suggest 4 boreholes in the boundary and 1 in center. But if it's a road work, we need kilometers, or a pipeline work. So a port. So we are doing certain port projects where you have 10 kilometers into the water. So you cannot drill everywhere. So we do sites of subsurface investigation, like sites, corner scan, echo sounders. So the grab samples we take, because we cannot investigate and drill everywhere. So that based on the type of the project, we keep working what is the geotechnical investigation data needed, and that is what stage of the engineering we are working. So pre-feasibility will be different, feasibility will be different, and once we feel that it is small, then for the design tendering stage we work out differently, and then design stage we work out differently. And for real execution, right now we are doing a project for Kochi Metro, just opening up the new block. So every peer I told we will go for investigation. Every peer, every pile we will investigate and collect data because of the uncertainties. So that is where we are going for the real execution, because we don't want surprise when we are doing that. So that is the phase 2 just opened up now. So we are about 450 boreholes to be done on that.
Right. So that basically depends upon the vulnerability of the project also, and the importance of the project as well.
Yeah.
There is a general question from Mr. Abdul. Demolition, is there in civil engineering curriculum, and in which university?
So I think that this is going to happen very soon. And I keep telling the people that there is before, when we do the survey or the grading of the soil, in the future, what is happened, the lifeline of the building is only 75 to 100 years. So you need to demolish that building first. With so many high rises, you have to come up with technologies like similar to this to bring it down. Then only you can grade the soil. So definitely this is going to be part of the curriculum. There is a book written by myself and Professor Nayak, N.V. Nayak. So that was his last book before he passed away. This November we completed the book. So it is just got published. So where I have done a chapter on the techniques of demolition and how it is going to impact. Definitely, I think the Jaypee University can take the lead to have this syllabus, because it is needed in the future when the technology is advancing.
Thank you, sir. We'll be needing teachers like you for that.
Yeah.
Okay, there is another question from Tejas. Sir, were the explosive used were cold explosive for the demolition of buildings?
It was mostly emulsion explosives. So emulsion and controlled explosives. So I am not an explosive expert in that, but then handling this, we are interacting with so many people. So we went for emulsion explosives.
Okay. And the question is from Chela. What's the significant depth as from the practical point of view?
Significant depth, which is the case study. Again, depends upon the soil. So if we are talking about the pile, so we have a depth of fixity of the file which is happening, which is the most vulnerable thing. Then whereas this thing, when an impact is happening, mostly the vibration is on the surface. So the surface is where we have to be very careful about, and there will be vertical as well as horizontal movement which we have to take care of consideration. We don't go much deeper to measure what is the impact happening. But since we had a gale pipeline which was 4 meter below, so we have kept instrument at 2 meter, 4 meter and 7 meter to understand what is the vibrations which is happening at these depths to monitor that.
All right. Sir, many of the contestants have asked for the PPT that you shared today, and also about the book about this explosives.
Yeah. So this the obviously I will send the PPT to you, and I always believe that knowledge has to be shared, and people should learn that. The book is Textbook on Construction Technology by Dr. N.V. Nayak and Anand, and it is published by Creative Books. It's available now in the market.
All right, sir. You please send me the PPT, and I think the people are filling out those the forms that are shared by Dr. Tanmay. Those are the feedback forms. I'll send those PPT to those participants who have filled the feedback form now. I'll invite, if there are any questions from the participants, they can unmute themselves and ask the question directly. Please unmute yourself and ask the question directly to the speaker if there are any questions with you. Yes, there's one raised hand from Manas. Can you please unmute yourself, sir?
Good morning, sir, and good morning, all of you.
Good morning, sir.
Basically, I am recently passed out student on geotechnical engineering and now as assistant professor. Sir, my question is, for a field we have investigation, preliminary investigation and detailed investigation. After we go for the construction, sir. But after construction, the soil will be change their behavior and demolition the building. So that time, how we can assume that 50% or 100% building will be not a demolition, but it will be working the condition of timing. So some structure is now B structure, like their demolition after 5 years, 10 years. So this is for soil behavior or construction misguidance or something what happened, sir.
Yeah, Manas, I was not very clear about the question, but what I understood is that, so you do investigation, later on you construct the building, and then you go for demolition. So most of these cases, we don't touch the foundation. Foundation is left as such, because recovering a 40-meter pile from below the ground is a big challenge. So generally we don't do that, and we allow the superstructure to come down and excavate that, and we make a borrow pit so that about that impact is taken at the base. If the basement is there, we are happy. If it is not there, we make pits to absorb the loading on that.
Okay, thank you, sir.
Thank you, sir. There is another raise hand from Mr. Raghavin Singh. Can you please just unmute yourself and ask the question?
Yeah, there is one. Would you please repeat the name of the textbook? It is Textbook on Construction Technology by Dr. Narayan V. Nayak and Anand J. Kadiwal, and the chapter 5 is written by me on exclusively on demolition techniques. It is going to be a must-learn subject for the engineers of the future, is what we believe in.
Okay. Raghavinji, can you please unmute yourself and ask the question directly?
Thank you, sir. Thank you, Joseph, sir. No any questions, sir. Kindly, sir. Please.
Thank you.
Okay. Next raise hand is from Mr. Abdul. Can you please unmute yourself?
Sir, good afternoon.
Good afternoon.
Sir, approximately after how many years the number of demolitions will exceed the number of constructions?
Very challenging questions. We have to wait and see. But then we have seen that there is a huge deterioration in the quality happening in the construction. And we should have a system, and India is not that rich to demolish. As a person, if somebody asks me, I am against demolition because we need to construct, and we are not rich enough to demolish 500 crores worth of asset in 9 seconds. But then this was a Supreme Court decision. Nobody can challenge that. But then the quality has to be ensured. There has to be systems in place so that we have to ensure that the demolition doesn't happen that much. But maybe in 75 to 100 years of cycle of the construction, because you cannot change a marine drive from that point to another. So, but then building get old. So 50 years, it doesn't match what is needed. So it's again depends upon the growth of the economy, growth of the thought process. So I feel, but then people will love heritage structures also. So maybe 50 to 75 years since the explosion of construction is happening, we will have demolition also happening simultaneously.
Sir, and the other question is from my side.
Yeah.
We need money for earning. At the same time, we need safety also. But people, will they prefer demolition or will they prefer for going constructions? As an engineer, we prefer to go for constructions or to prefer in a demolition side?
No, because the demolition is done, one, it is violated the law. So it is the direction of the Supreme Court. We have to do that. Other is that we have to come up with it, like I presented the Raheja case, where they want a 40-story building. So if they go for conventional demolition technology, like using crunchers, cranes, punches, drilling systems, it will take 1.5 years to get a 3 lakh square feet removed totally. But this takes only maybe including all the planning, it takes 2 months time. So your work can start and your building can come up. The new 40-story building can come up. So to create construction, you need to demolish the old building there. So that is what exactly we did at Mindspace Hyderabad for Reheja building. They are now going to come up with a huge IT building again. But this was also an IT building, but then it was outdated. So that is why this when it was no structural problem was there. But then that area was so prime that 8 floors was not sufficient for them to understand, and they feel that demolishing that and reconstructing is the right solution for them. So Reheja, one of the leading builder in the country, so they feel that that's a requirement based on their commercial need. So that can happen across the country.
Thank you, sir.
Yeah, Neeraj, you are muted, I believe.
Oh, I'm sorry. So there is another question in the chat box. Due to high number of high-rise structures, problems such as sinking of soils are happening. So is the practice of high-rise construction sustainable?
Again, very interesting question. China is facing a big problem due to water table. In fact, it's not the high rise alone. Due to the water table going down and drag down, and the sinking of the soil is happening. But if you do good engineering, so you can see that in the Middle East, they have gone that. So the Burj Khalifa is there, and now they are coming up the Kintan Tower, which is more than 1 meter tall. Or take Japan, which is a very vulnerable area, but they have so many beautiful high-rise structure with the good engineering practice, like base isolation systems, vibration dampers, everything has been done, and good study has been conducted, and they are doing that. So the high rises will keep on going. People are like us, the human society is interested to see some bigger, bolder, taller, and all, and the beautiful structures. It will keep coming, and it is up to us, the engineers of the future, especially the young people who are listening. About 125 people are there in this, and I'm very happy. So it is for you people to come up with technology which is safe, which is practice, which is relevant to the codes, and ensure that the buildings are constructed by engineers only. And that's the biggest drawback in our construction industry, where engineers doesn't have a say. So we have to be very loud and clear that this is my job, I will do it. And that is a professional way to get it done.
Thank you, sir. I think that was a very nice reply. And I'll call the participants. If anyone has any else a doubt, they can unmute themselves and ask the question to the speaker directly. So I think there are no more questions remaining. So with this, I'd like to have thank to you. If there are any doubts, please, you can still unmute and ask the question. Otherwise, we are going to close the session.
Sir.
Yeah.
Is the demolition is till now existing only for the exposed structures, or even this is possible for buried structures?
Primarily, we are doing only for the superstructure part. Buried structure we have not done so far, but in the future it might also come as a need, because all these things, if you look in, it's all this technology started with mining, this blasting and technology controlled demolition, and the tunneling. Tunneling is one industry which uses this so much. So there is a lot of things. Actually, the entire tunneling, so much of controlled blast is needed. So now we have technology where there is a 40-story building on top, and we are getting a tunnel right below that. So there are so many softwares now. So that's a big future for, especially in India, where we need so much of infrastructure growth in the next 30 years, that you will have to come up with technology. And this, it might not be demolition, but explosion at the lower ground below, without affecting the superstructure on the top, will be a big challenge for the new young geotechnical engineers coming up. So we have passion for that, because it's a very tricky thing, but then it's a very challenging and interesting thing.
In abroad, they have done, sir, similar type of any buried structures like a metro trains or anything?
I am not aware of the demolition done by implosion technology on underground structures, but the bridge structures they are doing. Many bridge structures in India also they have done.
Okay, sir. Thank you.
Right. Mr. Arman Chandar Katoch, do you have any question?
Yes, sir. Sir, I have messaged it, texted it in the chat box. So.
Okay. You,
yeah, I saw that. Yeah, the question was that, sir, what according to you should be the best suited solution for the rise of unorganized and unethical construction in terms of disaster management in reference to Shimla? What I suggested that, because I was part of the committee, I was telling the cases in Himachal as one case and Joshimat as other case. We should have a good engineering team monitoring what is happening inside, and only engineers should be allowed to practice, and proper testing, and this thing has to be made mandatory, and it has to be signed by an engineer, and policing has to be ensured, because if there is no control, so for this we want engineers bill passed. So only engineers should do, professional engineers should do only the engineers work, and then we can bring in all this into practice. And obviously the one of the most important aspect, because we don't have people taking core engineering now, it will also start improving, because we have to improve the status of engineers in the society. For that we need all of our supports to make sure that we are going in the right direction.
Yeah, there is another question in the chat box, that which software is being used for blasting activity in tunnel and underground structures?
So there are many softwares. There is a software called Blast, Creative. There are so many softwares available for the blasting, but it's all in infant stage. It's not because we did a recent one for Tata in Jamshedpur. We blasted in the Tata steel plant 2 of their huge chimneys and cold storage material. So they wanted to come up with the software. We worked on it for so long, because TCE is one of the best engineers in the country. But then to stimulate the exact explosion was a big challenge. We were not able to come up with a precise model, but we did a lot of attempt on that, and still working on different stimulations. So definitely there are a few commercial software available. And for the other modeling, we did Plaxis as well as ETABS as the primary softwares to model the surrounding structure, and structural simulations were done using ETABS.
Yeah. Just to call in the between, there is an important announcement that the Civil Engineering Department, along with the IGS Shimla chapter, is organizing an international conference on the civil materials and environment in the coming days on the 4th and 5th of October. So we are inviting the papers, and there is a call for paper. You can just visit the detailed link that is given there and submit your abstracts and the papers there. So there is another question from Mr. Ayush Gupta. Sir, you suggested only 2-story buildings in the Himachal Pradesh. How to sustain the rapidly rising population?
No. I told that any building more than 2-story, I wanted for every building. But then the government was telling that let us have some framework, 5-story building across the country now, and 2-story buildings in sensitive area, and anything above that has to be signed. I wanted for every building or every structure, there has to be a proper geotechnical investigation signed by a geotechnical engineer, and the foundation drawings has to be signed by a geotechnical engineer. They should be responsible. And if something goes wrong, they should be accountable also. That is what that's because when you are doing a professional job, you have to be sure that you are delivering that and you are responsible for that. And once that comes into thing, this is for minimum 2-story. We would like to have building, but then we have to ensure the safety and surroundings if we go for high-rise structures.
Yeah, exactly. So I hope there are no more questions left. If there are any other questions, please, you can unmute yourself and ask. Sure, sir. I think we have exhausted upon the remaining questions. And so can we close up the session, sir?
Yeah, sure. Thank you very much. It was a very interactive session and very happy that so many questions came in. And I congratulate the organizers and look forward to Samadhya sir's presentation tomorrow. And let's keep learning and implement it in the field and make sure that our structures are safe, especially when tragedies, especially you are in a highly sensitive zone in earthquake. And when these tragedies happen, let us make sure that our buildings are quite safe and we are saving life of the people. Thank you very much.
Definitely, sir. We'll take into account all the suggestions that are given by you and all the motivations for the chapter as well. Sir, once again, on the behalf of entire IGS Shimla chapter, the Civil Engineering Department, JUIT, and the IGS members, I like to congratulate you for that very insightful lecture. And thank you very much. Thank you very much for joining us. Just for the information, tomorrow we'll be joining again on the same platform at 12 o'clock. We will be having a lecture by our ex-president of IGS, Dr. Naren Samadhya, sir. So please be there tomorrow at 12 p.m. And
yeah,
please.
Thank you. Thank you, Anil. It was really very good, exciting lecture and related to the field. And tomorrow my lecture will be more beneficial to the students, especially third year and fourth year students, because it will be the something like academic side. May not be having that much of material related to your failure. But yes, I welcome you all for tomorrow's lecture. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Thank you very much. Thank you. Thank you to VC, sir.
Okay.
And our dean, sir, for joining.
Sabko namaskar.